Welcome to part 2 of chapter 14 on lean operations. So we concluded the first part talking about the personnel changes necessary for lean operation. We'll continue with that thread in the second part here. So another element of our personnel organizational is continuous improvement. So by now that you know that continuous improvement is the second of Professor DeLuke's 3 fundamentals. So we've talked about that quite a bit. So we need to continuously improve, and especially we need to continuously improve those processes that bring the value that our customers consider to be so important. So we need to build within our employees this attitude of continuous improvement. And I have to reflect back on my very first employer, Texas Instruments, and how lucky that I was to become an employee of that company, because the company had, from the day that I had initially joined, already a corporate culture of continuous improvement. And in fact, every employee, regardless of your position, was expected to make at least one improvement in the way that they do their job every year. So if you could not make at least one improvement in how you did your job, that was sending a message to management that maybe you weren't thinking about it as hard as you should have been. So we want to have a good positive pressure on our employees for continuous improvement. We want to encourage them, and we certainly want to recognize them for their ideas that they come up with. So public recognition of continuous improvement is very important to do. Another thing that we could do is change some of the ways that we collect our overhead costs using an accounting technique called activity-based counting. So activity-based counting, if we are measuring our labor in certain ways, activity-based counting kind of gives us a different perspective on that. So some of you accounting majors, I'm sure, will encounter this concept at some time in your accounting courses. Also, leadership and project management. So going back to my earlier comments about my students being the future business leaders of tomorrow. Leadership involves setting the direction, and leadership involves facilitating. And in many cases, leadership involves being the cheerleader. Leaders are not necessarily expected to always come up with the correct solution. So give your employees an opportunity to develop leadership. Give them an opportunity to learn project management. Now we'll move to our last building block in our 3 building blocks, and this is manufacturing process and control. And that's shown here on the title slide as just MPC. And there's a number of elements on it, and we'll take them one at a time. So the first one is level loading. The definition of level loading is we are producing about the same amount every day. Now this is extremely important in going lean. It's very important that our production output or our production volume does not have a great deal of changes to it. Because what are we trying to achieve? We're trying to achieve a smooth, rapid, balanced flow. If we are trying to produce one week 1,000 units of a certain part, and the next week 10,000 units of that same part, that's going to be very difficult to achieve some type of a smooth, balanced flow whenever the volume changes so much. So we have to come up with the ability of building about the same amount every day. And notice I'm saying about the same. I'm not saying exactly the same. And there are some techniques for achieving this that's documented in your textbook, referred to as sequence cycles in our products mix, is determining the optimum number of sequence cycles. In addition to a level loading, we would like, where possible, to achieve a pull flow. So an MRP system uses a push flow. In a push flow, we are assembling from the lowest levels of the bill of material and moving upward in the bill of material. So you always have to start with something at the basic level and build up. So we are essentially pushing from one level to another. Now, push flow has its advantages. It also has its disadvantages. One of the disadvantages of a push system is that it gives us the possibility of having excess inventory, especially when we push material to a higher level, but there is some other missing component and we're not able to move that, to actually use that material that we pushed there until the other component arrived. So it is essentially sitting there and we have the wasteful aspect of excess inventory. A pull system is when we pull output from the preceding workstation only when it's needed. So we are pulling from the top of the bill of material downward to the bill of material. And the big advantage of a pull system is that it eliminates this unnecessary, wasteful inventory being sitting there waiting to be used. So we only pull inventory whenever we need them. Now, the pull system, in my opinion, and in many others' opinion, in our implementation of lean operations, is the last thing that we do. The last thing that we do. Because the pull system can be viewed as like a house of cards. If you ever take a deck of cards and you start to kind of build a little pyramid or something with them, they're very unstable, and all it takes is the slight movement of one card and everything will come crashing down. Well, a pull system is like that. Everything has to be set up. The disruptions have to be minimized before we can go to this. So it's the last thing that you do. Communications. So as part of our pull system, communications is going to go backward. When I say backward, I'm talking about going to preceding workstations. And also as part of a pull system, flow arrives just in time. So the YouTube video that we saw earlier, we saw things arriving just in time, just as a customer in the delicatessen was ready for their sandwich or their drink or whatever, it flowed into their hands. Visual systems. So the pull system is usually, but not always, a visual system. And the thing that allows us to determine when we need to do something, that gives us a signal or a authorization to produce something, is called a Kanban system. The word Kanban is a Japanese word that translates into English into the word signal or visual record. So a Kanban is a card, a physical card. Think of a 3x5 index card, or maybe an index card a little bit bigger than that has some information on it, the part number, the quantity, And that particular card is associated with a container that is going to contain this particular material on this particular part. So the Kanban system is our authorization to produce or to order from a supplier. We could have different types of Kanbans. We could have a production Kanban card, as well as a delivery card for moving material from one workstation to another workstation. You could also have a third type of Kanban card that I have seen in my experience for ordering from a supplier. Now, one of the things that we need to be able to do is to calculate how many of these Kanban cards that we need to have. So a Kanban card and a container in which we're going to keep the materials, we'll kind of think of those as essentially the same thing. So we have a little mathematical formula for calculating this, and it's shown on this slide. So the letter N represents the number of containers or the number of Kanban cards. There's one card per container. The letter D represents what the planned usage rate is for that material at that work center. So we consume about so many of these units on some unit of measure per hour, per day, whatever. The letter T represents the average time it takes us to get a resupply of that part whenever we run out. So we have a supply of those parts in a container, and we're going to be using them to do some type of operation. Well, before long, we're going to run out. Well, how long does it take us to get another container that has a full supply of those parts? So T represents what that time is. X is a variable that represents essentially safety stock is what it actually is. Your textbook refers to it as a variable set by management for possible inefficiencies. Well, isn't that what safety stock is all about? To protect you against certain uncertainties. So that's what X is. X is usually represented as a percentage, like 20% or 30% or 10% or something like that. And then finally, we have the variable C. C represents the capacity, okay? So how many parts are going to be able to be put into this particular container? So every container, it has a fixed size, and we have for each part only one size container, and we have a certain quantity that can be held in that container. So here's an example of calculating how many Kanban cards that you need. I put an example in here, and if you see an example in here, you're going to see this show up on an exam, and you will have to calculate this on an exam. So in this example here, for this particular material, we are going to be consuming 50 units per hour. That is the usage rate. The time to replenish is 90 minutes. So it takes us 90 minutes after we have used all the parts in this container to get us a new supply in. And our safety stock variable is 20%. In other words, we want to have 20% more Kanban cards than what we actually need. And the number of parts that will fit within this container is 25 parts. So plug in those variables into the formula. So N is equal to dt times 1 plus x, and then divide all of that by C. So D is 50 per hour. Now, in this case, the replenishment time and the demand need to be in the same unit of measure. So 50 per hour, we have to convert the replenishment time to hours. Okay? So 90 minutes is 1.5 hours, so we've got that into the same unit of time measure. So in our formula, we'll use the number 1.5 for that. Our safety stock is 20%, so that's 0.2. And we do the calculation, and that calculates to 3.6 containers. Now, you always have to round up if you get any type of a fraction at all, and you most always will get a fraction. So, because you can't have a fraction of a container. You have to have an integer number of containers. So, the correct answer in this example is that we need to have 4 containers. We need to limit our work in progress. Okay, so work in progress means extra inventory. So again, the work in progress is going to be determined most likely by our safety stock and also by our lot size policy. So if we reduce our lot sizes, by very nature, it's going to reduce our work in progress. Typically, we need to have a closer relationship with our vendors or our suppliers in a lean environment. So, first of all, we're going to have fewer suppliers and vendors. We may even only have one supplier or vendor. And however many we have, they're going to be few in number, and they're going to be the ones that we can really count on. Because in a lean system, especially in a pull system, you just cannot afford to have a part shortage. You cannot afford to have a part shortage. So again, going back to the YouTube video, there at the end, whenever the customer paid by cash, that represented a part shortage. That represented a disruption. And we saw the effect that it had on the entire lean supply chain. So we have to have vendors that deliver on time. In fact, we may want to give, in many cases, these vendors additional privileges to actually come into our plant and bring the materials out on our production floor. That's done quite often, especially in the automotive industry. Okay, and also we might also want to implement vendor managed inventory, which we'll talk about here in just a minute. Okay. Many times, lean processing systems reduce transaction processing. Transaction processing is what occurs with our ERP systems. So, because things quite often are visual, this puts a less reliance on information systems. But please let us remember that these enterprise systems, we still need to do the accounting functions. So everything needs to eventually flow to the balance sheet and the income statement. So yes, we can reduce some transaction processing, but we cannot eliminate the transaction processing that's going to post the inventory, the accounting information that eventually flows to the balance sheet and the income statement. We need to keep our house in order. We need to do preventive maintenance. The definition of preventive maintenance is maintaining the equipment and, in fact, replacing parts that tend to fail before they actually fail. Before they actually fail. So, for example, if we have a machine that has a fan belt on it, so the fan belt turns, and eventually that fan belt is going to fail. Eventually it's going to fail. So we need to do periodic inspection of that fan belt, and when we see it starting to wear and start to have cracks in it that are indicators that it may fail in the future. Don't wait until it breaks and then the machine can't be used. Go ahead and change it before it actually breaks. We need to do housekeeping. In fact, one of the very first things that we typically do in the implementation of lean is something called 5S. Your textbook doesn't talk about 5S, but usually that's the very first step. And implementing 5S alone will have a tremendous number of benefits in reducing waste. So 5S is 5 different words that begin with the letter S. So the first word is sort. So if I have a lot of things I'm not sure whether they're good or bad, I have to somehow sort them out. And I sort them into 3 groups. One is a group that I don't need this anymore. I haven't used it in a long time. Throw it away. That's one group. Another group is this is something I need. I use every day. I want to keep it. And the third group is I'm not sure if I want to keep it or whether I throw it away. So we need to think about the third group. The group that is throw away, immediately throw it away. Set in order. In other words, a place for everything and everything in its place. Designate where each item goes. This is its place. It always goes right here. Shine. If it is in need of some type of repair or it needs to be cleaned or whatever, put it in good working order. Standardize. Let's make sure we do this all over the factory. And then sustain. If we ever see clutter starting to build up again, then we're getting away from 5S. Go through this again. Sort, set in order, shine, standardize. So a place for everything and everything in its place. And typically, that's the first step in our journey to going lean. Now, I put into the lecture kind of a comparison between traditional and lean. We'll talk about this. So from an inventory perspective, kind of a traditional system may want to have late deliveries where the lean is trying to go absolutely minimum. Deliveries from our suppliers. In a traditional system, we want to order in large quantities and have as few deliveries as possible. Where in lean, we want just the opposite. We want small quantities and we want many deliveries. From a lot size perspective, traditional, we typically have larger lot sizes, maybe even economic order quantity, which is larger, where lean is small. Setups, many setups in lean, where in traditional we have fewer setups. Suppliers, in lean, we have fewer suppliers and we have a closer relationship with them. And from employees, we view our employees as assets. We give them responsibilities. We listen to them. And in a traditional environment, employees are not viewed in the greatest light. So transitioning to a lean system. Here's a list of some things that could possibly get in the way. If you certainly don't have the commitment from top management, you're going to have a very difficult time doing this. Implementing lean works best whenever we choose those types of parts and so those types of products that are easier to work with. And we'll talk about some of those things. Sometimes it's easier to start small and lean. Pick a product line that you feel like lends itself to going lean and start with that. And if you achieve some good results, then you can start to incorporate the same results with those other products. Be prepared that there are going to be some difficult days. Going lean is extremely difficult to do. There's going to be a lot of pushback, usually from the employees. That's one of the reasons why we have to change our attitude in working with them. If we listen to them and we give them an opportunity to tell us where the problems are, their resistance to going lean will be reduced. So if management is not fully committed, if we don't have the cooperation of our employees, if we don't have our suppliers on board, these are things that could make this path to lean very difficult. Lean can also be implemented in the services industry as well. There are some things that we have to do differently whenever we do it, but essentially we're trying to do the same thing. We're trying to eliminate disruptions. We're trying to eliminate any waste. You may be interested to know that here at the University of Texas at Dallas, that a few years ago, our university president has designated that our campus and our processes will become lean processes. So he realizes the benefits of going lean here at the university, of reducing waste. If we reduce waste, we reduced cost, we reduced expense. If we reduce those, then we can keep our tuition rates down, which will be beneficial to our students. Just-in-time 2. JIT2 is a concept where we take this relationship with our suppliers and we kind of take it to the next level. The next level would be that we ask our suppliers to manage our own inventories. We are essentially outsourcing that responsibility of inventory management to our suppliers. Of course, before we do this, there's a great deal of trust that has to be built up. There's a great deal of information sharing that has to take place. So if we're going to be managing someone else's suppliers, we need to know what their inventory levels are today. We need to know what the demands will be for those particular products that we're going to be managing the inventory for, which means we have to give this information to our suppliers if we're going to ask them to manage our inventories. So VMI is a trend that has been taking place in operations management for some time, and it is a trend that will continue to take place. So from an operations strategy point of view, going lean is probably one of the most important areas that we could do. It works best in certain types of industries, certain types of products, and we'll take a look at where it works best in. So let's end this chapter by discussing the differences between lean and MRP, which we reviewed in a previous chapter. So from a production process perspective, lean works best where we have higher volume, where MRP works best where we have lower volumes. From a demand perspective, lean works best where we have a steady, level loading type of demand, where we produce about the same amount every day, as we said earlier. MRP works best if your demand is lumpy. That is, it varies all over the place. The benefits of both systems are the same. Both MRP and lean have as one of their benefits to reduce inventory. They just go about it in a different way. From a scheduling perspective, both systems are trying to, again, do the same thing. MRP and lean are trying to schedule things just when they are needed. Not any earlier, not any later, but just when they're needed. So from benefits and scheduling point of view, MRP and lean have a common goals, and they're trying to do the same thing, but they go about it in different ways. So their planning systems, lean quite often uses visual systems. A Kanban pull system is typically visual, where MRP requires a very sophisticated computer software. Lean uses a pull system, a Kanban system. MRP uses a push system. And lean works best where we have a shallow bill of material. What do I mean by a shallow bill of material? What I mean is we do not have a great deal of parts. So maybe something less than 20 parts within the product. There's a lot of products that have less than 20 parts. MRP works best where we have deep bills of material. So some of the products that I used to do material planning for, we had as many as 3,000 parts on the product, very deep bill of material. A lean type environment would never work where we have 3,000 parts. Remember, we can't afford to have a disruption. You can't afford to have a part shortage. If you have 3,000 parts, you're going to have part shortages. There's just no way of getting around that. So this concludes this second part of this chapter. This concludes the last chapter in the course. So I hope that you have learned some things about operations management and supply chain management, some things that will help you in your career.